My name is Matt Davison, and I'm the Dean of Science here at Western. Before we get started, and although we are gathered virtually today, I'd still like to make a land acknowledgement. I wish to acknowledge the Anishinaabe, Haudenosaunee, Lenape-Wauk, and Shawneton nations whose traditional lands encompass Western University. Western is committed to recognizing and furthering our relationships with Indigenous communities, and this verbal acknowledgement pays respects to the original peoples upon which the university is physically located, as well as recognizing the ongoing presence of Indigenous peoples in educational settings. All right, so homecoming is a rich tradition at Western. We have traditionally had lots of great in-person events, and we continue to do that this year. But during the pandemic, we were unable to meet in person for a few years. And so we started to think about how we might do some things online to involve our alumni in some of the great work that's going on in science. And although now we're able to have in-person events again, we figured, well, why stop the great opportunity to engage with people through talks, and that way people who maybe are far away and can't come in person, they can still experience some of what Western Science Homecoming has to offer. So our event today, we're going to have two incredible talks. Each one will be about 20 minutes with some time for questions at the end. If you have a question, you can write it to me in the Zoom chat, and our speakers will do their best to answer your question. Our next speaker is Professor Paul Mensink, and Paul will be presenting a talk called Education Through Immersion, the use of immersive technologies to foster engagement with STEM subjects. So Paul is a professor in the Department of Biology, and he's the director of graduate environmental programs in the Faculty of Science. Welcome, Paul.
Awesome. Thanks so much, Matt. And yeah, it's great to see some of the amazing things that you're doing, Anwar. Thanks for your presentation. I'm just going to share my screen here. Okay, great. So as Matt said, I'm working in the Faculty of Science, and what I'm going to try and tell you about today is a little bit about the ways we're using technology to teach science now, and that includes things like virtual reality, augmented reality, and mixed reality. So I'm going to go through a few of those examples here today for you. But I actually want to start off today by talking about where I see students when they're most immersed in some of the science we're trying to teach them, and that's typically out in the field. So we just returned from a field trip at the end of August that Western runs out to New Brunswick every year. And here we're showing students some of the organisms that are in tide pools. This is out in the Bay of Fundy, which is hopefully doing okay at the moment. And then in the bottom right, we're actually out looking for harbor porpoises on sea cliffs. So these are the places where I really see students are the most engaged. And but of course, one of the problems is it's very difficult to take students out to the field all the time. So, you know, we took 15 students out this time. We drive 16 hours to get to the coast. So the reason they are so immersed in the content when we're out there is because they can sort of have really hands-on experiences when they're there as well. But I don't know if my video is working there with you should be able to see the 2 feet moving, but I don't think we're seeing that. So hopefully the other videos will work here. So this next video is one way that we can bring sort of the field into the classroom. So these are 3D scans of what looks like a regular rock, which is actually completely encrusted with barnacles. So we can teach students about population dynamics. We can look at another seemingly innocuous rock here that actually has 2 species that live on that rock. So students can explore these 3D models actually in just from their own computer as well. If you want to know what the inside of your scallop that turns up on your plate looks like, This is an example of a sea scallop that you would get from out east. And students can look inside, see the light sensing anatomy on the edge of the girdle there. Or we can actually have students really explore species like crabs and without having to worry about the risks of students picking them up. But these are ways that we can actually capture what's in the field and bring it into the classroom. So how do we then maybe take students out to the field? So how do we do the opposite? So we've developed a range of different 3D virtual tours. So these places don't sound all that exciting in terms of the recycling facility, the landfill, and Western's power plant, but it's really important for us to show students how in real life our waste is managed, or things like how does Western try and reduce its emissions in terms of heating the campus. So this set of virtual tours students can explore, and they can do that as if they were actually going to the site when we use these types of immersive video headsets. So students can put their smartphones into the front of these headsets, and then as they move their heads around, the accelerometers in their phones track that movement, so they can look around just as if they were standing in the landfill or the recycling facility that's there. So we rolled these out in some of our classrooms, and students now regularly do these tours as part of their learning. So that's one way we can kind of take them out into the field, the way we can bring things back to them as well. Another kind of key mission for the university is to engage students in STEM research. So I myself work on basking sharks. So this might be an example of something I would show in a class. This is about the research that we were doing. We put on satellite pop-off tags on 4 different sharks and tracked where they moved off of the coast of Ireland. Now, I wish we had some sort of solution for 5G connectivity underwater and water, because that would be very helpful for tracking these organisms. But the sharks only come to the surface every so often. So, so there's issues with how we can track them. And so we try and teach students about satellite telemetry as well as part of this. But one of the things that is nice to do is maybe try and show them a bit how this information, how this research is conducted. So this is a video here of how we actually put satellite tags on the dorsal fin of a basking shark. So basking sharks are our second largest fish, so they can reach up to 12 meters in length. So we take the boat up behind the shark. The clips here attach with 2 golf tees onto the dorsal fin of the shark, and that pops off after a certain period of time. But what if, so I can show students that video, but what if I can let students experience what that is like? And that's what we did when we teamed up with the local creative company to build an augmented reality app to let students actually get involved in the research collection that way. So this is me in the university community center, and we can basically turn it into an ocean where students can track sharks. I can tag sharks with my finger. And so you can see here, I've just tagged another shark and I missed that one. But we can also turn our classrooms into underwater virtual laboratories. So this is one of our larger classrooms at the university, and it luckily will fit a basking shark. So that's very handy. So that's one way we're doing that. And I'm just going to show you some of the other aspects of that augmented reality app, which is freely available for anybody. So here you can see that we're now about 20 meters depth. There's a group of sharks swimming around us. You actually get swallowed by the shark at some point. We highlight areas along the shark's body for students to learn more about the anatomy there. It's all narrated as well, so students can use that. Here we're inside the shark's stomach now. We're looking at copepods that the shark feeds on. We talk about diatoms and phytoplankton, big drivers of oxygen production in the ocean. And then we take them down to 1,000 meters and we talk to them about the deep scattering layer and carbon sequestration in the deep ocean. And of course, we have to have a little bit of fun, so students get a chance to tag the fish or tag the shark, and I'll show you that again in a minute. This is what it looks like when we kind of sort of deploy it to the to a classroom here. Sorry, I'll just go here. So here are some students actually using it in one of our classrooms. So again, that ocean is superimposed onto the classroom area. They're tagging the sharks there with their fingers, and you can see the other students in the background that are doing the same. Now, augmented reality is a good option because lots of people have smartphones. It's very easy for us to deploy it that way, but it doesn't necessarily give you the sense that you're actually there. So on top of that, we've built a virtual reality app. So this is one that you would use with a virtual reality headset. We have about 30 of those virtual reality headsets here that we can deploy out into classrooms to allow students to get involved in some of those activities. So this is actually a video capture from inside the VR headset. So the person's moving their head back and forth, and then you can actually, with your own hands, pick up the pole to attach the satellite tag onto the back of the dorsal fin. I will say, having been in this myself, it's quite realistic, and other people who have gone through it have kind of had anxiety around the shark kind of coming up around them. We've kind of mapped this off of exactly the areas where we collected the information for the sharks that I was talking about earlier. And we turn this into a game again. So this encourages students to keep going, try and get as many as they can. We give them a minute and a half to try and tag as many as we can, and then students can compare scores across the classroom. So this lets you role play as a marine biologist and lets you sort of see what it would be like if you were actually out collecting that information. So then we allow students to go underneath the water as well. Now, this is something I would never allow any of our students to do in real life, but we can do it with virtual reality. So this is a basking shark here. So now you're kind of underwater and swimming with a basking shark. You can have it swim by you as it starts to feed. And when you're in virtual reality, it is a 12-meter long shark that's swimming beside you. So, on top of that, you can see the very sort of cloudy green water here is because of the density of phytoplankton in the hot spots where we find these sharks. Sharks will often aggregate in these hot spots, so the sharks start to swim around you as well. So you get this sense of being in kind of a school of these sharks as they're feeding in these really highly productive areas. These are also, we see these sometimes during courtship displays, these very kind of concentrated densities of sharks. So I'll just let that play for a minute here. And eventually our sharks kind of start to swim away on their own. But one of the other things that these sharks do is breach the surface waters. So often in large congregations, they'll come up and they'll actually breach the water. So now you get kind of a front row seat to those breaching events. And again, we can use this to kind of engage students in this content, in STEM content, particularly for me. I teach a first-year class of students. Many of them take my science course as a breadth requirement for their degrees. So this is a way that we can actually engage them with the science, particularly for people who feel they aren't science people. This is a way to get them engaged in that type of content. So on top of that, so we've got augmented reality, we've got virtual reality, but we can also do game-based learning. And one of the things we want to do, so we want to get them engaged in the content, bring the field to them, take them out to the field, put them in virtual reality. And this is something we can use to actually have students collect their own data, and then they can export that data, and we teach them how to analyze it. So instead of just giving them an Excel sheet of collected data, students can collect their own data. So this is a simulation we made that represents government monitoring of sea lice on aquaculture farms in BC. So you may or may not have heard that the federal government is shutting down open pen aquaculture on the West Coast. The main reason for that is because of the potential for sea lice infestation in the aquaculture pens. So here students are in the lab, they're taking samples. We developed 3D models of the sea lice. They count how many lice are on each of the fish, and then they take other measurements of the fish as well, including its weight. And then we export all of that data. So students actually are analyzing the data they collected as part of the simulation. So they can take sort of the personal responsibility for looking at the data. And that's really how we get them engaged in the data analysis part. And that's always a struggle. So getting them to be really interested in that once they've collected their own data has been really helpful. This is another game-based simulation that we've put in. And that one is around monitoring marine mammals. So these are aerial surveys for marine mammals just outside of the Bay of Fundy. So students can look around. We track their search patterns, so where they're looking within the game. They can take out a camera and they can zoom in on different areas of the ocean as they're flying over top. Here's a student who's found a pod of pilot whales. They take a photo of that. They count those, count the number of individuals, they export that, and then we teach them how to analyze, count data, and make informed decisions about conservation and management from that game. So from there, we're going to try and develop more of these types of materials, and this is a project that was funded by the Strategic Priorities Fund at Western, but we've built a Western Immersive Reality Education and Development Lab, or the WIRED Lab. And this is primarily for developing new immersive reality education, which spans anything from the game-based learning I showed you to augmented reality, mixed reality, where the virtual and real environments are mixed, or complete virtual reality as well. So in this space, we can have students develop content that we then deploy to our classrooms. They test it here, or we bring students in to experience virtual reality. We have a range of different headsets, ranging from ones that can monitor your eye movement and cognitive load. So when we're testing some of these experiences that we're building, we can determine, okay, no, this is too much for the student, and we can do that quantitatively by accessing biofeedback that the student is giving us through the headset. So I'll just give you a quick example of what we've been using that for. So students in our fourth year computer science course have been developing games for testing in the lab. And one of those is around recycling contamination. So we get a lot of students that come from across the university, or sorry, from across the province, outside the country, and in each of their municipalities, there might be different recycling protocols. So when students arrive here on campus, what we end up with is a lot of recycling contamination. So students are putting their recycling in the wrong spot. That means when it gets to the materials recycling facility, like the virtual tour that we had earlier, they just throw it out and put it into the landfill. So instead of diverting our waste from the landfill, our recycling actually ends up there because it's so contaminated. So the students built a game, a virtual reality game. I just have a little video of me testing it out in the lab here. So you can see on the screen to the left, I'm actually getting recycling is coming down a conveyor belt. I'm sorting it into the components that Western actually has on campus. So we can train all the students that are coming in to recycle properly. Now, we collaborated with a music student to create the soundtrack for this, which unfortunately you can't hear because it's being played through the headset, but we're bringing together groups of students from across the university to develop these games, and that includes students in the arts to help do some of the 3D modeling and some of the music associated with this as well. Now, some of the new things that we're working on is the technology in these headsets is moving along very quickly. And some of the new things that we are able to do is completely track your hands in virtual reality. So when you put the headset on, there I was using controllers to sort our recycling, but now we can actually just use your hands your real hands, they'll be mimicked in virtual reality, and you can pick up and move virtual objects with your own hands. So that's really cool, and that's something that we're working on developing a bit more now. And certainly because it's homecoming, I just want to say go Western, and hopefully we have a good win today. But there's lots of different things that we can do with this technology. And these are just some of the ways we're trying to implement it within Faculty of Science to really engage our students with STEM content. Just wanted to very quickly thank some of the funders of this project, which includes Unity, which is the game engine used to develop Pokemon Go. eCampus Ontario is funding us to further develop that augmented reality app. And again, Western supported the development of the Wired Lab. Thank you very much, everyone, and very happy to take any questions.
Thanks, Paul. Again, you can text me or use the Zoom chat to send me a question if you have a question for Paul. But I'll get it started this time as well. So Paul, I was fascinated by simulating being in the deep ocean and seeing the sharks. How do you know what to put into that simulation? I mean, do we have enough data from the deep ocean to?
Yeah, that's a good point. So we have a lot of the satellite tracking data we have time depth recorders on those tags, so we know how deep they're going, and we know that they must be accessing the prey fields that are in the kind of deep scattering layer within the ocean. So things like gelatinous zooplankton that they might be feeding on, and we know then from baited remote underwater video what sorts of organisms are down there, and we know that there's marine snow, so dead organic matter that's falling from the surface. So we kind of combine all of those things that actually, you're making a good point. We're actually combining all of these things to create something that you probably would never be able to actually capture in real life, because we're combining from multiple information streams. So yeah, it's a kind of a design twist.
That's awesome. I have a question in from Mohammed. Thanks, Paul. These are all great tools. The positive impact on these tools on student engagement is evident. And Mohammed's question is, did you notice any impact on students' learning?
Yeah, so I didn't mention it, but around all of these projects, we have research studies going alongside of them. And so one of my major goals, as I was mentioning before, we have students that are kind of from outside of science taking our science courses, is to kind of close the gap in engagement between our science and non-science students when they're learning about STEM content. And we actually see that when they're using these kind of virtual reality or augmented reality applications, we can close that gap a bit. And so that our non-science students are actually engaged enough to be more in a kind of a level playing field. Now, the other thing that it does as well, though, is it takes science students and engages them even more than they were before. So we are able to do that through using these applications as well. So absolutely.
I really like even the fish lab example where you're doing maybe some relatively routine measurements, but doing them together is totally different than just seeing them written in a spreadsheet. You have a much more visceral feeling for what it is that you're doing.
Yeah, and that's when we're out on the field course, when the students are collecting their own data, that's when they have ownership over it. And that's when they say, oh, I want to see, I want to look at the analysis here. They can see that, oh yeah, I remember that fish had 30 lice and that's an outlier. And we teach them about outliers. And so,
right.
So yeah, when they collect it themselves, that's how we can really get them interested in that component of it.
So another question's come in from Christina. And her note is, hi, it's great seeing the engagement through the virtual reality, augmented reality. Do you see this type of learning becoming available to high schools in the future? Absolutely, particularly through as headsets get cheaper and cheaper, we're basically going to move to a situation where every classroom is going to have headsets. There's already high schools that have VR labs that are running students through them.
But particularly with augmented reality, students in high schools could use that now, because most of them have smartphones that basically have the processing power to implement those augmented reality apps. So as we go forward towards more of these kind of virtually hybrid campuses, yeah, we're going to see a lot more of VR, AR, and mixed reality, and the technology is just going at like an incredible pace. And in fact, some of the things we have now, in the next 5 years are going to be outdated. It's moving so quickly.
So I think here's another question from Rebecca. I get motion sickness with VR. Is this seen as a limitation with any of the students?
Yes. So under the current headsets, motion sickness can be an issue. There's actually design kind of practices that you can use to reduce that. But also, as the technology gets better, the resolution is coming up to basically eye resolution. So what you're going to be seeing, you're going to be having a difficult time differentiating whether you've got the headset on or off, and that will help with those types of motion sickness as well. But as the technology gets better, that rate of motion sickness is dropping substantially.
So I was interested, Paul, when you said that some students are getting startled by or almost frightened by these sharks that they clearly knew were not actually in their classroom, but it was still freaking them out. So that, is that common? Is that?
Yeah, when you're actually in virtual reality, there's actually a simulation we take them through that goes to Antarctica, and at one point a penguin hops out of the water up onto your kayak. And it's kind of a start, and every time people kind of have that startle response. Again, even though they know that they're just standing in a room, they feel like they're in that environment. And I think that aspect of the technology is the real advantage to get people engaged with the content that we're talking about.
So I think to wrap up a little, I'd like to just offer some reflections on both of the talks we had today. First of all, it's something I'm so proud about for Western Science, that we're able to participate in some of these very cutting edge activities on the research side, on the education side, and what we're seeing is that those two, something that we know and believe already in our profession, that research and teaching are not really distinct things, that one informs the other, and they're two sides of the same coin. And part of teaching is getting students engaged in and excited by research, and part of research is thinking about how we can better educate people in the using all the tools at our disposal. And it's great to see, and I'm proud that our faculty is embodied by Anwar and Paul, but also by many other of our fantastic faculty at Western Science are really pushing the envelope on all of these things. So thank you again, Anwar and Paul, for your fantastic presentations today. I hope everyone enjoyed the presentations, and if you're able to, if you're not in London and you've just sort of connected in for an hour to be part of science, we're so happy to have had you join us. If you are in London and maybe you're going to be at some of the other events today, we look forward to seeing you shortly. But regardless, either way, I hope everyone has a fantastic day. Thanks everyone for coming, and bye.
Thank you, everyone.